So, limits involving infinity. These ones are kind of nice because you just have to, they don't require much calculation. It's more of just like a do you know this one, do you not know this one kind of thing. So it says you can learn a lot about a function from its asymptotes. So looking at its asymptotes, you can learn a lot whether or not they're vertical asymptotes or horizontal asymptotes. So it's important that you can determine what kind of asymptotes shape a graph just by looking at a function. It says remember that asymptotes are lines that a graph approaches but never reaches or touches. So it's the graph that stretches out forever and ever. So the two types are vertical and horizontal asymptotes. Do you have a question?
No.
Sorry, you're just looking at me.
The screen.
Why?
Because I hate asymptotes.
Oh, they're not that bad. They're great.
No, they're not.
It says in the graph below of g of x, x equals -2 is a vertical asymptote. So if you look at -2 from the left-hand side, it's going to positive infinity. If you look at -2 from the right-hand side, it's going to negative infinity. And the horizontal asymptote is at y equals 4. I'm sorry, you have a horizontal asymptote and it follows that. So notice here how limits are integrated with that. So limits can either go to infinity or you're taking limits at infinity. Do you guys see the difference between going to infinity and limits at infinity? So going to infinity means that the limit actually equals infinity, which means it would go up or down forever. A limit at infinity means what's it doing as it goes towards x equals infinity. So that's what that means. So that's why the limit would equal 4, because as it goes to positive infinity, it follows that asymptote, and as it goes to negative infinity, it follows that asymptote. And so both obviously follow 4. Does that make sense?
Yeah.
Okay, cool. So let's continue. So it says determine which discontinuities of this are caused by vertical asymptotes. You guys don't necessarily need to write this one down because I think we've done it like 4 times today. Do you remember how to find out if it has a vertical asymptote or a hole? Good. So if we do x plus 2 on the top, and then on the bottom, what does that factor to? X plus 2, x plus 3. So at x equals -2, is that a vertical asymptote? That is a hole. Why is that a hole, Katie?
Because you can cross them out and it's just...
Good. You remove them. That's a removable discontinuity. That's a hole. What about x equals -3?
It's a vertical asymptote.
Good. Vertical asymptote. Perfect. Next. You guys don't need to write this one down either because it's not really like a evaluation one. It's more of like, do you know this concept? So is this a limit going, my bad, let me move that back down, there we go. Is this a limit going to infinity or a limit at infinity?
Limit at.
Good. This is a limit at infinity because they want to know what is it doing at infinity. So it's pretty much saying, as we go towards positive infinity on the x-axis, what is this doing? What do you notice, or what do you know about these ones? Are these the vertical ones or the horizontal ones? The horizontal ones. So what do you know about polynomials, f of x and g of x? What do you know about polynomials as far as figuring out their horizontal asymptotes? They don't have any when. There's 3 cases. If these are both polynomials and this is a rational function, there's 3 cases that the horizontal asymptote could be at. Do you remember them? It's kind of a weird question, so I understand I might be asking it kind of weird. Uh-huh. The degrees. The degree of the top and the degree of the bottom. When we look at that, that's what tells us the horizontal asymptotes. So good. If the degree of the top, so we'll say n is the degree of the numerator and d is the degree of the denominator. So if n is greater than d, so if the degree of the numerator is greater than the denominator, which one's that? None. So that one is no horizontal asymptote. What about if the degree of the numerator is equal to the degree of the denominator? Good. It's the leading coefficient of the top divided by the leading coefficient of the bottom. And what about if the degree of the top is less than the degree of the bottom? Good. That would be y equals 0. Perfect. So a lot of times on the AP test, you'll see, or I shouldn't say a lot of times, but sometimes on the AP test, you'll see a limit at infinity. Always, 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 first thing that should come to your mind is horizontal asymptote, because you can't evaluate a function at infinity. It's the horizontal asymptote thing that's going to help you out with that. So keep that in mind as we go through. Or I should say it's not easy to evaluate it at infinity. All right, so using what we just talked about in the last problem, what's the limit at infinity for this function? Why, Anthony? Good. 4 is greater than 2. That means n is greater than d. So that means there is no horizontal asymptote. And because it is a limit at infinity, it's implying what are the horizontal asymptotes. So there are no horizontal asymptotes. So the limit is does not exist. Limit does not exist. All right. So Essentially what that means is because there are no horizontal asymptotes, it doesn't follow a specific number. That's why the limit does not exist. So it's either going to go to positive infinity or negative infinity. It's not going to follow any specific number. All right. What about this one? What is it? How do you get that?
Because when you take the square root of, you're kind of like dividing the exponents by 2.
Good.
So it'd be 3 over 5.
Good. The leading coefficient to the top is 3. The leading coefficient to the bottom is 5. That means it has a horizontal asymptote at 0, which means the limit as x approaches infinity, so the limit at infinity, is going towards 0. So this one has a limit of 0. So can you imagine taking the AP test and then seeing this problem and not remembering that just means horizontal asymptote and just being like, I don't know how to do that. Right? So when you see that limit as x goes to infinity, right, the first thing you should do is be like, oh, that's right, that's a horizontal asymptote. Because how easy is this problem as soon as you remember that? So it's important to remember that the limit at infinity is talking about horizontal asymptotes. All right, take a minute to try this one. Oh my gosh. All right, what's this one? I hear -7/5. Good. What might have tripped you up on this one? Right? Just because the 3 is first doesn't mean that that's the leading coefficient, or the highest degree. So the highest degree here is 4. The highest degree here is 4. So we get the limit equaling -7/5. Good?
Yes.
Okay. Give the equations of the vertical and horizontal asymptotes. So I'm going to let you guys do this one on your paper just so that you guys have it written down.
Horizontal is 2.
Brain tired?
Huh?
Or is your brain tired?
A little bit, but I snapped back.
Good.